All right, in this video, we're told to prove that 1 minus cos 2 theta over sine 2 theta equals to tan theta. The very first thing you always have to look into while trying to solve questions like this is because you are told to move to show that this left-hand side is equals to the right-hand side. So you have to evaluate everything and understand the direction you would have to take. Now, I can recollect that my tan theta is obviously sine theta over cos theta. So this can give me sort of like a clue on some of the things I have to do and some of the things I should not do. So from my knowledge of double angle, I know that I can rewrite this as my denominator will be 2 sine theta cos theta. The reason why I decided to hold off on changing the cos 2 theta is because I wanted you to understand the hang around how to make your movement in order to achieve the right answer. So now I know my sine 2 theta, this is it. But for my cos 2 theta, I have three different formats. One of them has both cos and sine. That's the one where we have cos square theta minus sine square theta. This is one of the formats of cos 2 theta. And we can also write this as, for the double angle, we could also write it as 2 cos square theta minus 1. And then we can have 1 minus 2 sine square theta. So all these are all valid ways of writing cos 2 theta. But in determining which particular format we're going to use in this particular question, we have to look at both the denominator and where we are headed. Now I can see that I'm headed towards tan theta, and tan theta obviously is sine theta over cos theta. So I'm much more inclined to try to lean towards this particular last form. Although the reason for that is because if I'm able, I can see from here that this particular format has sine square theta, and I can see right here that I have sine theta here. So I know that in whatever I'm doing, sine theta, if I'm able to cancel this sine theta and one of them there, I'm already seeing my sine over cos coming out, which is the particular destination we are moving towards for the answer. So I'm going to decide, because of that reason, to be using this format. So I'll be writing 1 minus my cos theta. I'll be writing it now, my cos 2 theta rather, as 1 minus 2 sine square theta. So opening this, I have 1 minus 1 plus 2 sine square theta. Everything over 2 sine theta cos theta. 1 minus 1 obviously is what? 0. 1 cancels 1, so I'm left with 2 sine square theta over 2 sine theta cos theta. From here, I can also see that the 2 here cancels this 2, and also you can see that the sine theta here will cancel one of them right here. So this gives me the leftover. I'm left with just 1 sine theta here over cos theta. You can see that this is quite very simple. Sine theta over cos theta is obviously the same thing as tan theta. So I've been able to prove that my left hand side, which is this, is equals to my right hand side. All right, let's see a different question again. So let's look briefly at this particular question. We're told to solve this. So again, we have cos 2 theta right here. And I told you there are 3 different formats we can use. Whichever one you decide to use, just note one thing: when you're trying to solve trigonometry equations, you have to try to blend everything to just one trigonometry function. So you take, for instance, I decided to use the first one, which was cos square theta minus sine square theta. Of course, this was one of our formats. Now, this will not be very good because we must have the same trigonometry function. In this case, we're having 2 different functions. We're having cos theta, we're having sine theta. So we have to make use of, we have to adopt our sine squared theta to be 1 minus cos squared theta, which will take me to my second format. That will be cos squared theta minus 1 plus cos squared theta equals to 0. This will be 2 cos squared theta minus 1 equals to 0, which is our other format. So rather than you using this initially, you could have just fixed this in. But for you to just understand the reason why we cannot just use this, because we have to have the very same trigonometric function. So this is what we'll be using. And from what we have here, in order to solve this equation, we have to go on to use our knowledge of algebra, which will be, you cross the minus 1 to the other side. So we have cos squared theta will be 1 over 2. That means we can say cos squared theta will be 0.5. So in this case now, for you to solve this, you have to take the square root of both sides. So if you take the square root of both sides, obviously you'll be left with cos theta here, and you'll be left with plus or minus, the square root of 0.5 is 0.7071. Now I want you to understand that this is very key to be added. You don't just want to write plus alone. The square root of an answer is not just the positive side of it, it's also, the negative side is also featured. So endeavor you always fixing plus or minus when solving questions like this. So this brings us to our application of angle of any magnitude. We have to make use of angle of any magnitude here. So you'll be solving for when cos theta was equals to the positive side of 0.7071, and then also you'll be solving for when cos theta is equals to the negative side of 0.7071. So in solving that, of course, the first step I told you to always do is to go on to find the arc cos of this value. So the arc cos of this, obviously, if you press this on a calculator, you will get your theta to be 45 degrees. So now, for us to use this to solve these two values, because it's the same thing you would do if you were dealing with the negative side also. So we have our theta being 45 degrees. But how do we find the answer for this? Of course, I've told you before that when you're solving this particular question, you have to look at the sign, and then you go on to investigate using your quadrant. Where would your cos be positive? Because in this case now you have cos being positive here. So your cos is obviously positive in the first and the fourth quadrant. So that means for this particular side of things, you'll be dealing with the first quadrant and you'll be dealing with the fourth quadrant. So, and I told you already that when you are dealing with the first quadrant, all you have to do is to replicate whatever you had here before. So in this case, your theta will be 45 degrees. But for your fourth quadrant, the rule that functions inside the fourth quadrant is 360 minus theta. This will be 360 minus, in this case, we have our theta to be 45. So this will give me a value of 360 minus 45 is obviously going to be 315. So we have 315 as our answer. So for this particular side of things, when cos theta was positive 0.7071, our values, our theta, our angle is 45 degrees and 315 degrees. So these two are our answers for this particular side of things, but we have to go on to find for this other side. So for this other side now, we have our cos being negative. So we have to go and investigate where cos is negative. If cos is positive in both the first and the fourth, obviously cos will be negative in the second and the third. So our quadrant of interest for this second side of things is quadrant 2 and quadrant 3. So for our quadrant 2, the rule that goes on in quadrant 2 is 180 minus theta, our theta being 45. So that will be 180 minus 45 degrees. And 180 minus 45 degrees gives you what? Well, you get an answer of 135. to 135 degree. I told you already that your quadrant is what determines the final result. So for the second, for quadrant 3, what the rule that goes on there is theta plus 180 degree. Our theta is 45 degree. That will be 45 plus 180. So 180 plus 45 obviously will give you an answer of 225. So our values when we are dealing with this other side was 135 degree and 225 degree. So our final answers for theta will obviously be, our theta was, number one, we had 45 degree, then we have it as 135 degree, then we have it as 225 degree, then we also have it as 315 degree. So these are our values for theta when we're given this particular question. Don't forget what we're solving for in this question. We're solving for theta being between 360 and 0 degree. So this gives us the final answer for our question. I really hope you were able to solve this, and I'd love you to get your hands dirty with this particular question. You're given this question. We have 3 tan square theta being equals to 3 sec square theta. So how do you resolve this using your knowledge of trigonometry? So I would love you to give me your feedback, your answers in the comment section. All right, guys, thank you for joining us. I hope to see you in the next video. Bye-bye.